We'll start at 9 o'clock sharp.
Inshallah.
Thank you, Dr. Syakirin, for joining us for the second time.
So these are different student, different batch of student, right?
Sorry?
The groups that are joining us today. So the group of student that is joining us today is different from the one that I taught in the previous year.
Different students. So the current student have 4 groups.
Okay.
For 2 lecturers. So
Okay.
I'm teaching 2 groups and Dr. Nur Izan teaching the other 2 groups. They are in
Okay.
semester 5 of electrical engineering program, power.
Okay. Okay. Practical power. So today we have a student from all sections or only your
All
student?
section, all the 4 groups, all the students that registered for this group have to attend this collaborative teaching.
I see.
And this recorded
Interesting.
video will be sent to the UITM for collaborative teaching for their evidence.
Okay.
The attendance of the student, the pictures, the recorded link will be sent via the report.
Okay. Interesting. We should do this often, more often.
Inshallah.
Inshallah. Next time I will invite you to do teaching to my students as well.
Okay, inshallah.
Inshallah.
Okay, it's already 9 o'clock. Assalamualaikum and good morning to everyone. I would like to introduce all of you, Dr. Syakirin Ramli, from Fakulti of Electrical and Electronics Engineering Teknologi, Universiti Malaysia Pahang. We used to be in the same department when I was working in Universiti Malaysia Pahang from 2005 until 2010, before I moved to UITM in 2011. And a little bit of education background of Dr. Syakirin. He received his Bachelor of Science in Electrical Engineering from Purdue University, USA in 2005. And in 2006, he achieved his Master of Engineering in Electrical, specializing in Mechatronics and Automatic Control from UTM Skudai, Malaysia. And in 2015, he received his Philosophical Doctorate in Electrical Engineering from Kanazawa University, Japan. So without further ado, I would like to invite Dr. Syakirin again for collaborative teaching for the topic of state space. And for today, he will go through the matrix calculation that will be used in the state space model for for modern control system. That will be in our third topic. That will be in third question of your final exam. Please welcome Dr. Syakirin.
Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Bismillahirrahmanirrahim. Thank you very much to Dr. Najidah for inviting me to deliver this topic. And we did the collaborative teaching in the past semester, in the past year. And then again, Dr. Thank you again for Dr. Najidah for inviting me. All right, the topic that I was assigned is the modern control system. So this is the subject, right? So we have the topic is going to be on the state space. So I believe that all of you already have this slide provided by your instructor. So just to go through about the subtopic that will be delivered in this in the main topics. So I believe that I'm not going to be able to cover everything, because from the past experience, if I'm not mistaken, we were only able to discuss only on the first subtopic from the overall listed topic, and the rest of the topics I believe was covered by Dr. Najidah after the sessions. Right. So these are the topics that will be that was highlighted ataupun was the topics listed in the chapter of the state space. So we will be going to discuss about the state space equation, and then we try to understand about the eigenvalues and the closed loop pole, whereby this is going to be related to the system stability. So we know that I believe that most of you have learned about a system is stable if we have all the closed loop pole are located on the left-hand side of the complex X plane. So this can be translated in terms of the eigenvalues whereby we will see that if we have all the eigenvalues derived from the system matrix of your system are all negative, and then we can say that the system is going to be stable. So this can be related back to the location of the pole when we are working on the transfer function. And then of course, another topic is going to be the converting from the transfer function to the state space, and then converting back from the state space equation to the transfer function. And then of course, you will be learning about the signal flow graph, state representation, and then to determine the controllability and the observability of a given system. Right. So before I proceed, can you guys see this slide clearly from your end? Can get
Yes,
some
Dr.
feedback from you
Syakirin.
guys? All right, thank you.
How about the students? Can you see the slide clearly, the shared screen by Dr. Syakirin?
I hope there's
Yes,
no lagging, right? Tak ada lagging, because yesterday there was a problem with the internet connection in my campus, in
Okay.
UMP. So I hopefully there shouldn't be any problem today. Right. So these are the learning outcomes that is stated for this topic. So at the end of this topic, you should be able to explain the concept and technique of the state space. And then, of course, you must be able to convert from the transfer function into a state space representation, as well as converting back from the state space representation into the transfer function. And then the last one, you must be able to determine the controllability and the observability of a given system. So these are the topics ataupun these are the outcomes that we expect student will be able to obtain by the end of this discussion, by the end of this topic. So as I mentioned earlier, we are not going to be able to finish everything by within these 2 hours. I just try to cover as up until the topics as the time permit, and the rest of the topics will be delivered back by the Dr. Najida. And then we have the cost outcome and COPO mapping. And then I believe most of you already know about the program outcomes. Your department have, I believe you got 12 program outcomes, right? From your department. And then this subject ataupun this topic, this course is mapped to your program outcomes. And then the cost outcome is to identify a system using the state space and discrete time system, and then to analyze the performance and stability of the system using the root locus, recursive response, state space, and a discrete system method. So I just mentioned this, and then the detail will be you can further get the information from Dr. Najida. Right. So to give you a brief idea about the comparison between the classical and the modern control approach, right? I believe that in the previous semester you learned about the classical control, whereby you have learned about the root locus, the Bode diagram, Nyquist, and the Nichols chart. And then this is all these techniques fall under classical control theory. So we call it as a classical control theory. And then we have the state space is known as a modern control theory. Okay, maknanya kita of course there is a advantage and disadvantage offered by this kind of control theory, and then of the limitation of the classical control and so on, as you can see from the slide here. We have the analysis of the transfer function is applicable only to a linear time invariant system. So that means that if we were to use the classical control approach in designing our controller per se, so we are limited to assume that our system must be an LTI system, linear time invariant system. Meanwhile, if we were to use the model control approach, or we were to use the state space approach, we can extend our dynamics of the system, not considering only on the LTI system, but we are able to use other non-linear, or we can also use we can extend our study into the linear time varying system as well. So that's the powerful of using the state space domain ataupun the state space equation in representing our system, right? And of course, if we were to use the classical control, it is limited to single input, single output kind of system, whereby if we were to consider for the case of the multiple input, multiple output kind of system, there will be some limitation for us to analyze or to investigate the system if we want to use the classical approach to get a better understanding on that particular system. Right, so that's why that's important for you guys to learn about the state space equation. And then, of course, the classical control, the approach is simpler, and but the model control ataupun the state space equation, we have the capability for analysis for both linear and the nonlinear system, and then we can also use it to analyze ataupun to investigate the performance of the multiple the MIMO system ataupun we call it as a multiple input multiple output kind of system, right? So this is just as a brief review about the state space. Okay, so we move on to understand about the state space equation. So sekejap Okay, saya minta maaf tadi. Saya bawa anak ke office sebab anak saya demam hari ni. Jadi saya minta dia diam sikit kat belakang tu. Alright. Okay. Space representation is a mathematical model of physical system as set of input, output, and state variable related by first order differential equation or difference equation. So if we were to represent or if we were to consider for a continuous time system, if we were to consider for the continuous time system, we call it as the first order differential equation. But if we were to consider for a discrete time system, and then we call it as a difference equation. So there's the difference between why we call it as a differential equation or difference equation. Kalau kita nak represent bagi continuous time system, kita panggil dia differential equation lah. But if we were to get a representation for a discrete time system, we call it as a difference equation. All right. So this kind of the system can be represented in the state space domain by the following equation. So we got the x dot equal to ax plus b u of t, x dot of t equal to ax of t plus b u of t. So we call this as the state equation. And then we have the output equation denoted by y of t equal to cx of t plus du of t. Right. So this one you guys have to remember. Okay. Yang mana we have the dynamical system represented in terms of first order differential equation is given by x dot of t equal to ax of t plus bu of t. And then we have y of t equal to cx of t plus du of t. And then we have the name for all these variable, whereby x is the state vector, and y we call it as the output vector. A is called as the system matrix, C is the output matrix, and then we have U is the input or the control vector, B is the input matrix, and D is the feed forward matrix. And of course, x dot is going to be the first derivative of the state vector. So if you want to further your study in a master degree ataupun a PhD, and then you want to analyze if your study is going to be in control, normally we will be working using the state space equation to model our dynamical system. Alright. So bentuk dia macam ni lah. Maknanya parameter dia, kita akan ada state system matrix, output matrix, and then B is the input matrix and D is the feed forward matrix. Okay. Right. So these are the notation available in the state space equation. So we got remember that we have the state equation denoted by x dot of t equal to ax of t plus pu of t. And then we have the output equation denoted by y of t equal to sec x of t plus pu of t. Right. And of course, if you have any question, you can just stop me anytime, and then I'm happy to repeat again if you have any confusion or you cannot follow me clearly. Right. So we can express, okay, in terms of the block representation. So remember that this is not block diagram, but this is the diagram to illustrate this state equation. So recall that we have x of t, okay. Our dynamical equation, we have x dot of t equal to ax of t. Okay, kita ada x dot of t equal to ax of t plus bu of t, and then y of t equal to cx of t plus du of t. Right? So we know that if we normally when we want to obtain this block, ataupun we to try to understand the block here, so we have the integrator. Okay, we start with the integrator, and then of course the input of the integrator is x dot of t. So whatever signal passing through an integrator will be integrated. So we got the output here is going to be x of t, right? So x of t is comes from the integrator, okay, the output of the integrator, and then you can see that the signal x dot of t is equal to ax of t. Kan kita ada, this is going to be the signal x of t feed through the matrix A, okay, plus with b times u of t, okay, b times u of t, right? So we have this part of the first component here come from the state equation. Okay, the component here come from the state equation, and then we have our output equation y of t. So we have y of t is equal to c, the output matrix, multiply with the state matrix of x of t, y of t equal to cx of t plus du of t. Okay, du of t. So this is how the representation of the surface equation can be noted into the this diagram. So again, this is not the block diagram per se that you already learned in the classical control method. This is just the representation to denote, to express, we derive it from the state space equation. All right. Okay. So to understand the state space representation, of course, whether we like it or not, we should have knowledge on the linear algebra. Okay, linear algebra. I'm not sure whether you have a specific course that cover on the linear algebra. Saya rasa ada kan subjek matematik kan yang cover dekat under UiTM punya syllabus linear algebra. So this is just a review about some of the knowledge that you have learned in your linear algebra course that will be used to understand about the state space representation. Right. Okay. So let's move on to understand, to do some review about the matrices. Okay. So of course, we know the first one is going to be the square matrix. Okay. The square matrix is normally denoted by okay, we have apa tu? A matrix with equal components. meaning that we have a number of row and the number of column is the same. So we call it as the square matrix. And if you were to read some research paper, normally we denote the square matrix. For example, we got a real n by n. Okay. Kan, sebagai contohnya, kalau kita nak express our matrix A is a subset of real number of 2 by 2. Okay. Okay, 2 by 2. So meaning that we know that our A, matrix A is simply A11, A12, A21, and A22. Right. So this is one of the example to illustrate the square matrix. Right. Of course, we also have the non-square matrix, okay, denoted by the row, the number of row and the number of a column is not the same. For example, we have a matrix of B is a subset of 2 by 1, okay, ataupun 3 by 2, for example, 3 by 2, meaning that we have our matrix B is we have 3 rows and 2 columns, B11, B12, B21, B21, B22, B31, and B32. Right. So you can see that the number of column is not the same as the number of row. Number row ni we have 3 rows and 2 column, and this is expressed. This is the example of the non-square matrix. And of course, we have the row vector denoted by, for example, we got the row vector of C is equal C in 1 times 3, implying that our C is C1, C2, and C3. We have a single row, but m number of columns. For this particular example, we have 1 row with 3 columns. Okay, so we call this as the row matrix. And lastly, we have the column matrix. Okay, normally we express our column matrix is in terms of n. Okay, in the research paper, you will see whenever you see R here, I forgot to mention, R is the set of real number. Okay, R is the set of real number. Okay, real number, and we have this is a matrix. Okay, real number n to imply that this is the column vector with n row. Okay, for example, we got our x. Okay, x equal to x1, x2, x3, and x4 to imply that x is the dimension of the state vector x is R4. Okay, the dimension of the state vector x is R4. So this is just to give you to do some revision about what kind of matrix that we have that you will see when we discuss about the state space equation. Get a square matrix, non-square matrix, row vector, and the column vector. Right. Okay, let's move on to another type of matrix. Okay. So the next one is the null matrix. So of course, as the name implies, all the element in the matrix is all zeros. So that's why we call it as the null matrix. Okay. For example, if we have a null matrix of 2 by 2, so it's going to be 0, 0, 0, and 0. All the components inside the matrix is all 0. So when we have that, that is called as the null matrix. Meanwhile, the identity matrix is the matrix is a square matrix. So again, this is square matrix, but all the component, all the element in the matrix is 0, except on the diagonal part, whereby the element in the diagonal element will have the value of 1. Okay, the value of 1. Maknanya kalau we have the identity matrix of I4, implying that this matrix is a 4 by 4 matrix. Okay, but the diagonal element is gonna be we will have the value of the element in the diagonal is gonna be equals to 1. Okay, 0, 0, 1. Okay, so ini adalah example of the identity matrix with dimension of 4. Right. So kenapa saya tulis I4 ni, biasanya kalau dalam research paper you will see lah, kalau you will find that the researcher will use I4 to denote this is the identity matrix with the element of all the diagonal element is equal to 1. Right. Similarly to the identity matrix, we do have the diagonal matrix, but for this particular matrix, the diagonal element is not necessarily equal to 1. It can be any value, okay, depending on the system. So for example, we got the matrix A equal to 1, 0, 0, 0, 3, 0, 0, 0, and 5. Okay. So this is the diagonal matrix. We have all the elements in the diagonal is equal. We only have values, non-zero values on the diagonal, but the rest of the element is just equal to 0. Right. So this is called as the diagonal matrix. And the last one we have we call it as the adjoint of a matrix. Adjoint of matrix, the adjoint of the square matrix. So note that this is a square matrix. A written as the adjoint of A is the matrix formed from the transpose of the matrix A after all elements have been replaced by the cofactor. So what is the transpose of matrix A? Katakan we have a matrix A is equal to A11, A12, A21, and A22. Okay. Right. If we were to get the transpose of the matrix A, implying that the columns element becomes row element. So we have, this is going to be A11, A12. Okay, ini kan A11, ini adalah A12. And now here we have A21, A22. Okay, A21, A22. So this is what it means by the transpose A. This is the matrix A, and this is the transpose of the matrix A. But the adjoint of matrix A, okay, the adjoint of matrix A, okay, we have all elements have been replaced by the cofactors. Let's move on to the next slide to understand about the adjoint of matrix. Okay, so the next slide tu ada. Okay. So we have the matrix A. So this is the matrix A. Okay, ini adalah matrix A. We can have the cofactor matrix is given by this expression. If we were to memorize this formula, it's going to be confusing lah. So do not memorize. Jangan memorize formula ni. But please do understand how the cofactor matrix is formed. The way we form the co-matrix, for example, if we were to get the element in this A11 ataupun C11 punya column ni ataupun cell ni, we take a look at here, and then we take the determinant of this element. So you can see that we got for this component is going to be A22, A23, A32, and A33. We find the determinant of this component. Okay, we find the determinant of this component. And then we proceed to here, okay, A12, implying that Ataupun you boleh katakan kita tutup line ni, tutup kolom ni, kita tutup row ni. Kemudian kita ambil yang ini, A21, A31, A21, A31, A23 dan A33, kan? A21, A23, A31 and A33. We find the determinant of this matrix, and then okay. You must remember that if we were to find the cofactor of this matrix A, okay, we should be alternating in terms of sign. Okay, first we start with the positive sign. We got the determinant of this cell, and then we have the negative sign. We take the determinant of this cell, and then, okay, if we were to get the component of this cell, so you can imagine that we close this line, and then we determine the determinant of this cell. A21, A22, okay, A21, A22, A21, A22, A31, and A32. Okay, so we can do the same. We can do the rest of the cell by applying the same approach, whereby if we were to find the component of this matrix here, okay. So let's try to get some mental illustration on how we can get this we can fill in this matrix. You can see that kita tutup row ni, tutup kolom ni, okay, and then now we have A12, okay. We find the determinant of this. A12, A13, A32, and A33. Okay, and then we find the determinant of this matrix. Then, for this part, you can see that we close this second column. We close the second row. Okay, and then we take A11. So we have A11, A13, A31, and A33. We find the determinant of this matrix. And the last one, okay, we close ataupun you can imagine that we close this line, and then we close this line, and then we take the determinant of this. A11, A11, A12, A31, and A32, and then we find the value of the determinant, and then you can see that the sign is going to be alternating. So first we start with plus sign, minus sign, plus sign, and if we were to have a 4x4 matrix, the next one is going to be minus sign. So dia kan alternating antara setiap row tu dan juga column. So that is the cofactor matrix. And then if we were to find the adjoint of the matrix A, we need to transpose this matrix. Okay, tadi baru dapatkan dia punya cofactor. To find the adjoint, you have to apply transpose on this cofactor matrix C. Right. Boleh Okay. Tak nampak wajah student memang agak tak tahulah. Biasa kita rely pada facial expression kan. Jadi if student nampak blur je, so kita tahu dia tak faham, so we can repeat. But when we deliver lecture secara online ni, so it's very challenging to know whether they do understand about what we are talking about. Alright. So again, if you have confusion ataupun got question to ask, feel free to raise your hand, and then you can on your mic and ask me. Right. Itu adalah adjoint of the matrix A. So move on to the transpose of matrix. So again, I have explained before about the transpose of the matrix A. So whenever you see A with apostrophe T tu, maknanya ini adalah transpose of the matrix A. A dengan script of T, itu adalah matrix A, is formed by interchanging the row dan juga column of the A. So if A is n by m matrix with the element of A, I, J, the transpose is n by n matrix with the elements of A, J, I. Okay. Maknanya kalau kita ada matrix A sama dengan A11, A12, A13, A21, A22 dan juga A33. Okay, we can get our transpose of the matrix A. Row become columns. Okay, interchanging between row dan juga column. So we got A11, A12, A13, A21, A22 dan juga A3. A22, A23, A23. Right. Okay. So be careful on writing between square bracket dan juga apa ni, palang tu kan. Okay, my student have this problem to differentiate between this is a matrix and this is the determinant. Okay, so students still sometimes some students they got confused between on how to write the notation of matrix and to write the notation for determinant. Okay, so if you want to write matrix, please use square bracket, and if you want to write determinant, please use the parallel bracket. Right. Okay, so some of the property of the matrix transposition. Okay, so let's say we got a matrix A times B transpose is just simply equal to A transpose times with the B transpose. Maknanya kalau kita ada matrix multiplication, we got matrix A multiply with the matrix B and then we transpose everything. Is just the same as we transpose matrix A, we transpose matrix B and then we multiply A transpose dan juga B transpose. Right. So similarly, if we have a three matrix multiplication of three matrices, A times B times C transpose is just the same as the A transpose, B transpose darabkan dengan C transpose. Right. Okay, so that is the transpose of a matrix. Okay, so we move on to discuss on the some matrix operation. Okay, so this is a very straightforward punya apa tu knowledge. Okay, we know that we can add, we can subtract matrices. So for example, if we were to add matrix, what we have to do is we will be adding element by element. Okay, we will be adding element by element. For example, if we have a matrix A is denoted by 1, 2, 3, 4, and matrix B is 5, 6, 7, and 8. Okay. A plus B is simply equal to 1 plus 5, we got 6. Okay. 2 plus 6, we got 8. 3 plus 7, we got 10. 4 plus 8, we got 12. We should be adding element by element. Okay. And of course, the dimension ataupun the size of the matrix must be the same. Otherwise, how it's going to be, how we want to add. For example, if we have matrix A equal to 1, 2, and then matrix B is 3, 4, 5, 6. So you can see that matrix A is 1 by 2 matrix. Matrix B is 2 by 2, kan? 2 kali 2. So you can see that it's very difficult. We cannot achieve. We cannot add matrix if they are not in the same dimension. Right. So samalah. Subtraction pun sama. If we were to subtract matrix A minus B, what we have to do is we will be subtracting element by element, implying that matrix 1, element A11 minus with B11, 1 minus 5, we got minus 4. 2 minus 6, we got minus 4. 3 minus 7, we got minus 4. 4 minus 4, we got minus 4. We should be subtracting matrices element by element. Right. Okay. So next we have the matrix multiplication. Okay. For the matrix multiplication, if we have apa tu 2 by 2 matrix, for example, for this particular example, we have A, B, C, D. So let's call this as the matrix A, okay, times with X. Okay, katakan ini adalah matrix A, ini adalah matrix X. Okay, A times X is equal to A, B, C, D times with X. X dan juga Y. What will happen ataupun the operation in the multiplication, we got A multiply with X. A akan multiply dengan X, tambahkan dengan B. Okay, B multiply dulu dengan Y. Okay, B multiplykan dengan Y. So you see that for a matrix multiplication, the column element, okay, column element untuk matrix A multiply with, the row element of the matrix A multiply dengan column. Okay, row darabkan dengan column. So kita dapatlah AX tambahkan dengan B times Y. Similarly, for the second row, we got CX, okay, CX plus with DY, plus with DY. Okay, plus with DY. Right. So itu adalah matrix multiplication kalau kita ada A adalah 2 kali 2, B 2 kali 1. So we can directly multiply between matrix A dan juga matrix X. So, boleh kita multiply tak A darabkan dengan X? X darabkan dengan A. Untuk student lain, boleh ke kita multiply? Kalau, okay, adakah sama AX sama dengan XA? Kalau matematik biasa, 2 kali 5 sama dengan 5 kali 2 kan? 2 kali 5, 5 kali 2 kan? So we got 2 times 10, 2 times 5, 10. 5 times 2, 10, also 10. But is it the same as A times X? Is it the same as X times A? Okay, sama ke tak sama?
Tidak.
Okay, it's gonna be not the same. Okay, you have to be very careful on the dimension ataupun the size of the matrix when you want to perform the multiplication between matrices. Right. So multiplication is not by element. Product of 1 by n matrix and n by 1 matrix is a scalar. So kita dapat scalar quantity. Product of n by 1 matrix dan juga 1 by n matrix is n by n matrix. Okay, n by n matrix. So for example, if we have a matrix A dan juga matrix B, ini adalah matrix A, katakan ini adalah matrix A 2 kali 2, matrix B pun 2 kali 2 dia punya dimension. So you can see that when we want to do the multiplication between matrix A and B, okay, matrix A and B, we are multiplying A multiply with U plus with B multiply with V. So we add up these two multiplication, we got the value in this component ataupun this cell. Similarly, if we want to get the here, it's going to be A times X, kan A timeskan dengan X, tambahkan dengan B timeskan dengan Y, and then we get this value. Similarly, for this cell, we got C times U plus D times V. And here we got C times X plus D times Y. C times X plus with D times Y. Right. Okay. Again, this is just a review on the linear algebra that you have learned in the math class. Right. So kita ada matrix A, B, C is a 1/3 matrix. Okay, is 1/3 matrix. X, Y, Z is 3/1 matrix, 3/1 matrix. And if we were to multiply between these two matrices, you can see that the result is going to be a scalar. Okay. One way to check whether our multiplication is correct or not, ataupun to know whether the size of the multiplication is correct or not, is looking of the dimension. For example, here we got this 1/3 punya size, okay, and then kita akan darabkan dengan 3/1 punya size, okay. So you can see that the resultant is equal to yang ini dan juga yang ini. Okay, so that's why we got finally the size of the this matrix multiplication we got is going to be 1/1. Okay, so sama juga kalau kita ada AXZ darabkan dengan ABC. Okay, maknanya kita akan dapat X multiply with A, X multiply with B, X multiply with C. And then for the second row, we got Y multiply with A, Y multiply with B, and Y multiply with C. And the third row is Z multiply with A, Z multiply with B, and Z multiply with C. So you can see that this the size of this vector is 3/1. Okay, 3/1. Meanwhile, the size of this vector is 1/3. The result of the multiplication of 3/3. Okay. So if you are familiar with MATLAB, okay, if you are familiar with MATLAB, if you want to do direct multiplication, kalau tak sama size ni, dia akan ada error. You can try lah selepas kelas nanti, you can try. So the trick is you have to put some dot. Okay, for example, you define katakan we got matrix A equal to 1, 2, 3. Okay, B is 4, 5, 6. So dalam MATLAB lah, just sedikit sharing sajalah. Okay, kalau you type A star B dalam MATLAB tu, dia akan keluar error lah. Maknanya you kena pastikan letak titik dekat sini, and then it will do the element multiplication, and then you got the appropriate result. Right. So generally, A times B is not the same as B times A. So tu kamu nak kena ingat lah. Maknanya 2 kali 5 is not the same in matrix operation. 2 times 5 is not the same as 5 times 2. 2 kali 5 tak sama dengan 5 kali 2. So you have to be careful on this dimension of ataupun the size of the matrix that you want to perform the matrix multiplication. So to multiply any two matrices, they have to be compatible. To get A times B, the number of columns of A must be equal to the number of rows of B. For example, A is K times N. Size of the matrix A adalah K, K number of row, N number of column. B adalah B pula adalah N number of row, M number of column. Maknanya kita nak kena pastikan compatible kat sini lah. N dan juga N ni. And then you will get the correct multiplication. And then we can perform the matrix multiplication. Right. Okay. Kalau dalam kelas biasanya saya akan suruh student buatlah, tulis kat sini kan. Maknanya we do this exercise and then you take a piece of paper and then to write to do this simple operation, and then we can check during the class discussion kan. Tapi bila secara online ni kita kena tunjuklah sikit-sikit, and then the rest of the problem you can do it based on your understanding. So how we do the addition, matrix addition A plus B. So definitely straightforward. A we add element by element. A plus B adalah negatif 3 tambah 4 kan. So dapat 1, okay, A plus B, negatif. Ya. Okay, so let me rewrite everything so that we can see it clearly. Okay, we got a matrix A is -3, 1, -2, and 0. Add with matrix B is 4, 5, 7, and 9. Okay, and then we do the addition element by element, implying that -3 plus 4, we got 1. 1 plus 5, we got 6. -2 plus 5, -2 plus 7 is 5. And 0 plus 9 is 9. Okay. And then if we were to get the solution for the second problem here, so we got B plus A transpose, implying that our matrix B is 4, 5, 7, and 9. Plus with the transpose of the matrix A, we know that A is a -3, 1, and -2, 0. The transpose of the matrix A is -3, 1, -2, and 0. Okay, so we can have this gonna be 4 plus -3 is 1, 5 plus -2 is 3, 7 plus 1 is 8, and 9 plus 0 is 9. Right. So I leave the problem number 3 as part of your exercises lah. Maknanya you try buat sendiri, and then you can discuss with your instructors whether you get the correct solution or not. This is a very straightforward punya example. Okay, let's move on to the next slide. Right. So fine, we got 3 matrices. A is 2, 3, 4, 5. B is, okay, the dimension, A is a square matrix. B is, we call it as the fat matrix. Okay. Tadi saya tak mention kan. Okay, we have a tall matrix dan juga fat matrix. Biasanya kalau untuk row matrix tu kita panggil dia sebagai fat matrix lah. Kalau untuk yang column matrix tu kita panggil dia sebagai tall matrix. Okay. So the matrix B is 2 times 3. The dimension of matrix B is 2 times 3. The dimension of the matrix C is 2 times 1. Okay. And then if we want to find the products between A, B, okay, we have the matrix A times B. A darabkan dengan matrix B. Straightforward, we got this is A, 2, 3, 4, and 5. Multiply with the matrix B. Okay, matrix B adalah 1, 3, 5, 2, 4, and 8. Okay, so we will have the solution is, macam mana kita darab dia? So we take the row component, the first row, multiply with the first column of the matrix B. And maknanya we have 2 times 1 plus with 3 times 2. Okay. And then okay, space. Okay. And then we have here 2 times 3. Kan? Kita akan dapat 2 times 3 plus with 2 times with 4. Okay. And then the next one is going to be 2 times 5. 2 times 5 plus with 3 times 8. Right? So that is the multiplication between the first row of the matrix A multiply with all the columns of the matrix B. Okay, maknanya 2 darab 1 tambahkan dengan 3 darab 2. tambah, okay, comma ni, I put the comma here, okay. And then we got 2 times 3 plus with, ni 3 ni, this is plus with 3 times 4, 3 times 4. And then here we have 2 times 5 plus with 3 times 8. Okay. We do the same thing on the second row of the matrix A, whereby we have this going to be 4 times 1 plus with 5 times 2, comma, okay. Kemudian we have 4 times 3 plus with 4 times 3 plus with 4 times 4, okay. And then 4 times 5, 4 times 5 plus with 5 times 8. Okay, 5 times 8. So the resultant is going to be 1 darab 2, 2 campur dengan 6. 2 campur 6, 8. 2 darab 3, 2 times 3 is 6. 6 plus 12. Ini 12 kan? 3 darab 4, 12. 12 campur 6, 18. Okay. Kemudian we got this is 2 times 5 is 10. Campurkan dengan 3 darab 8, 24. 10 tambah 24 is 34. Okay. 4 times 1 is 4 plus 10 is 14. 12 plus 16. 12 campur 16, 28 kan? 16 campur 12. 28, okay. And here we got 5 kali 4, 20. 20 plus 40 is 60. Right. So that is the matrix multiplication between A and B. Do I need to show for the rest of the multiplication? So tak perlu lah ya. Itu saja dah. Okay, it's very straightforward punya products between matrix A dan juga B. Right. Again, this is just a review on what you have learned in your math courses. Okay. Right. Macam ni pula. We got the following matrix A, B, and C. How can we show that A plus BC transpose equal to A transpose plus BC transpose? Macam mana kita nak tunjukkan persamaan ini ataupun equality ini valid kan ataupun sama? How can we show that? Any idea? Macam mana kita nak tunjukkan 2 campur 5 sama dengan 5, macam mana kita nak tunjukkan 2 darab 5 sama dengan 5 kali darab 2? 2 kali 5 kan? So how can we show that A plus BC transpose is equal to A transpose plus BC transpose? Any wild guess? Okay, just to give you some idea. How do we show that 5 times 2 is 2 times 5? By looking at the solution, right? So 5 times 2 is 10. 2 times 5 is also 10. So even though they look not the same, but the final answer is the same. So we can conclude that 5 times 2 is 2 times 5. So same thing apply here. If you were to show that A plus BC transpose is equal to A transpose plus BC transpose, what you have to do, compute yang ini dulu, kemudian compute yang ini, and then if you are able to show that they have the same result of the multiplication, and then you can conclude that these are the same. Right. Similarly for BC transpose sama dengan C transpose B transpose, what we can do, you calculate BC transpose first, B times C, and then you transpose it, and then on the right hand side you calculate C transpose. You transpose matrix C first, and then you multiply with the B that has been transposed, and then you compare the solution between when you compute using this approach and this approach. If they get the same answer, and then you can conclude that BC transpose equal to C transpose sama dengan B transpose. B transpose, C transpose times B transpose. Alright, so that's how we show some equality expression. Inilah idea mudahnya, 5 kali 2 sama dengan 2 kali 5. Jadi kalau kita nak tunjukkan dia sama, tengok jawapan 10 lah kan. Right.
Dr.
Okay.
Syakirin, can we have
Yes.
5 minutes break?
Sure.
Okay, so let's have 5 minutes break. We continue at 10:05 minutes. Thank
Right.
you.
Teknologi dah yang digital control, tab apa semua ni yang part of the syllabus apa ni? Di bawah topik subjek yang sama lah.
Betul.
Okey.
So dia ada 4
Student
topik ni lah. Root locus, frequency response, design. State
okey.
space dengan digital control bukan design. Kita dah remove the design part daripada state space dengan digital control.
Okey. Tapi semua tu di bawah subjek
Modern control.
CEE ni.
Betul.
ESA 5559.
Betul, modern control.
Baik.
Modern control ni kita offer untuk power student sahaja.
Okey.
Electronic
Undergraduate lah.
student, untuk electronic student kita offer control design. Topik dia frequency response dengan root locus sahaja. Tapi memang
Frequency
fully design.
respon dengan okey. Design tu maksudnya design controller
Compensator lah.
ke
PID,
compensator?
lead lag.
Okey, mana fokus banyak kepada compensator design menggunakan root
Betul.
locus lah.
Root locus dan plot lah.
Okey. Kalau yang ini, subjek ni?
Subjek ni sama juga, root locus dengan frequency response design. And then ada
Okey.
additional topic state space dengan digital control. Yang ni bukan design.
Mana ini bukan design lah, just introduction lah. Kalau dia tak masuk lah apa tu state feedback controller tak discuss kan?
Tak.
Okey.
Dia just dapatkan state space equation, dah, that's it.
Okey. So ada additional ataupun ada subjek lain pula yang cover untuk state space state feedback controller?
Rasa macam tak ada. Betul tak Dr. Izan? Rasa macam tak ada.
Tak ada.
The next one kalau student power dia nak ambil electric, dia terus continue masa 7 semester process control.
Process control.
Process control dah tak cover dah state space feedback.
Dipakai apa tu transformation je kan?
Betul.
Baik.
State space sampai sini saja, subjek ni saja kan Dr. Izan?
Ya betul sampai sini je. Gambar tak keluar pula.
Okey. So boleh kita continue?
Boleh Dr. Syakirin silakan.
Okay, Bismillahirrahmanirrahim. Okay, thank you very much. So let us continue on the another topics under this main topic of the state space. Okay, determinant. Okay, previously I have mentioned about the way we write the equation in terms the equation for matrix and determinant. As I mentioned that from my experience, some of my students still got confused between matrix. For example, we have A sama dengan 1, 2, 2, 4, okay, using the square bracket. Between A, we have A sama dengan 1, 2, 2, 4. Okay, so this representation ataupun the way we write a matrix and the determinant, okay, if you want to represent matrix, if what you mean is a matrix, you have to use the square bracket to indicate that you are writing matrix. And then if you want to express determinant, you have to use the parallel bracket ni. Maknanya bila orang matematik tengok dia nampak lah kalau you buat katakan you tulis ni kan 1, 2, 2, 4 ni, so determinant is a mathematical operation, it's not a mathematical representation kepada matrix A ni. Right. Okay. So let's try to understand what is determinant. Okay. Determinant only apply ataupun we can only compute determinant if we have a square matrix. Maknanya kalau kita ada rectangular matrix, we are not able to get the determinant unless we do some manipulation kepada kita punya matrix. Okay. The determinant of the matrix n by n matrix written as absolute A ni. Okay, is a scalar valued function of A. The familiar form of the determinant from n 1 to 3 are, kalau n sama dengan 1, determinant of A adalah A11. If we have if we have the two dimension, okay, maknanya macam inilah. A is a 1, 2, 2, 4. We can have the determinant of the matrix A. Okay, the determinant of the matrix A. Saya padam dulu. Okay. For this particular example, we got the determinant of the matrix A adalah determinant of 1, 2, 2, 4, implying that we have this is 1 times 4 minus 2 times 2, and then we got this is equals to 0. Okay, determinant bukannya matrix, kan? Determinant of the matrix we got a scalar valued function of matrix A. Kita akan dapat scalar value. Right. So for the higher order ataupun higher dimension of the matrix A, how do we compute for the determinant of those matrix? Okay, ada beberapa three methods. Okay, method 1, method 2, and the method 3. Okay, let's try to observe to get some basic understanding about the difference between these three methods. Okay, take a look at the first method. We want to determine the determinant of the 3 by 3 matrix. Okay, 3 by 3 matrix. What we can have. Okay, method yang pertama. Tertinggal pula. Okay. So this is the first method. Okay. The way we compute our determinant adalah, okay, we take the first column here. Okay, it's gonna be A11. We can find the determinant of the matrix A sama dengan A11, kan? A11 multiply with the determinant of the cofactor ni, which is A22, A22, A23, A32 dan juga A33. Right? Okay, yang ni kan, you can see kita kembali bayangkan we tutup ini, tutup yang ini, dan kemudian kita ambil yang ini A22, A23, A32 dan juga A33 minus minus A12, A12 darabkan dengan tutup yang ini, and then kita ambil determinant yang ini. So which is going to be A21, A23, A31 and A33. Okay. And then plus. Okay, nampak we alternate plus minus kalau kita ada 4 kali 4 plus minus, okay, plus with A13 tutup yang ini, so this one is going to be A21, A22, A31, A32. Right, itu kalau untuk yang 3 by 3. Okay. Right. Implying that we will have this going to be equal to A11 darabkan dengan A22 times A33, A22 times A33 minus with A23, A32, okay, minus with A12, A12 pula, multiply with A21 darabkan dengan A33, A21 darabkan dengan A33, okay, tolakkan dengan A23 darabkan dengan A31, tambahkan dengan yang ini pula, which is A13, darabkan dengan A21, darabkan dengan A32, tolakkan dengan A22, darabkan dengan A31. So if you were to expand this expression, and then you will get as the one that given in your slide ni. Okay, the way we obtain this equation is simply by following this expansion. Right. So that is the first method to obtain the determinant of the matrix A for the case of the 3 by 3. So you can apply the same thing for 4 by 4, 5 by 5 and so on. But I believe that at most paling tinggi pun kita bagi 3 kali 3 lah kan biasanya kan, if you want to consider for a higher dimension of matrices, and then it's going to take a long time if you want to do it by hand. Okay, so for big matrices normally we employ ataupun we use MATLAB to do the computation for us, but as you still need to get some basic understanding on how the determinant is computed. And then this is the method to determine the determinant, the first method to compute the determinant for a case of a 3 by 3 matrix. Right. Itu adalah first method. Second method, okay, slightly different from the first method. What we do to compute the determinant, what we can do is we can repeat, okay, we repeat the first two column. Kan, kita repeat the first two column. So we got the matrix A, B, C and so on. We rewrite ataupun we repeat the first two column, put it on the sebelah kanan sebelah kanan ini, and then we multiply diagonally. Okay. For example, we have the one in the red arrow. So we got A multiply with E multiply with I times plus with B multiply with F multiply with G plus with C multiply with D multiply with H. Okay, A E I plus with B F G plus with C D H. Then kita tengok pula yang biru tu. Okay, minus with C multiply with E multiply with G minus with A multiply with F multiply with H minus with B multiply with D multiply with I. Okay, itu adalah metode yang kedua. Maknanya kita rewrite balik the first two column sebelah kanan ini, dan kemudian kita we multiply diagonally, and then untuk kita dapatkan dia punya determinant value. Right, slightly different from the one we compute previously. Method 1 guna cara ni lah. Method yang kedua kita tulis sebelah kanan dia. So method yang ketiga is another approach to compute for the determinant of 3 by 3 matrix adalah dengan kita repeat first two row. So we got A, B, C, D, E, F, G, H, I. Kan? A, B, C, D, E, F, G, H, I. And rewrite the first two row A, B, C, D, E, F under here. Okay. And then to compute the determinant of this 3 by 3 matrix is simply we multiply diagonally A, E, I tambahkan dengan D, H, C tambahkan dengan G, B, F. Kan yang warna merah ni. Kemudian tolakkan minus with C, E, G, F, H, A dan juga I, B, D. Okay, I, B, D. Right. So that's the three methods on we can use to compute for the determinant value. So tengoklah mana-mana method yang you rasa comfortable nak guna. I think you can enhance your skill in using that method. Right. Right. So that's how we compute for the determinant for a case of 3 by 3 matrix. Right. Okay. Kenapa nak kena faham macam mana nak cari determinant ni? Sebabnya nanti kalau kita nak convert daripada transfer function kepada state space patah balik kepada transfer function, we need to use all those knowledge that you learn in your linear algebra class ni. Okay, let's take a look at this example. I believe we will not be able to do it all. So let's pick up one of the example here. So nak try yang mana? Kita try yang B dululah. Okay, let's try to compute the determinant of the matrix B. Shift S. Sekejap, saya nak try screenshot, tak boleh screenshot. Okay. Okay, kita try compute determinant matrix B tu menggunakan kaedah tadi. So we have our matrix B is equal to right. So this is our matrix B. Okay, let's try to use the second method to compute determinant of matrix B. So second method maknanya kita nak dapatkan matrix B, determinant of the matrix B, we have 2, 3, 0, 6, 5, 0, and 1, 2, 1. Kemudian we repeat the first two column of the matrix B, implying that we got 2, 3, 6, 5, and 1, 2. And then we multiply diagonally, yang ini, dan juga yang ini, tambah. Kemudian tolakkan dengan yang ini, dan juga yang ini. Okay. Implying that we will have our determinant of the matrix B, okay, is equal to 2 times 5 times 1 plus with 3 times 0 times 1 plus with 0 times 6 times with 2. Kan, yang kuning ni kan. So ini akan jadi tambah 2 darab 5 darab 1, tambahkan dengan 3 darab 0 darabkan dengan 1, tambahkan dengan 0 darab 6 darabkan dengan 2, minus with, okay, minus darab yang ini pula, which is 0 darab 5 darab 1, tolakkan dengan 2, darabkan dengan 0, darabkan dengan 1, tolakkan dengan 3, darabkan dengan 6, darabkan dengan 1. Right. So we will have our determinant is equal to 2 times 5 is 10, plus 0, minus with 0, 0, and 18. Minus 18. So lastly, we got the determinant of the matrix P is simply equal to minus 8. Okay, sama dengan minus 8. Right. So that's how we compute the determinant by using method number 2. Okay, ini kita pakai method nombor 2 lah. So this is when we use method 2. Right. Let's take a look another example to use method 3. Okay, kita cuba yang E ni pula. Okay. Cuba yang E ni pula. We try to use method 3. Okay, so ini adalah method 3. Okay, maknanya we want to compute the determinant of E using method 3. What we have to do is we will repeat Okay, kita ada S 1, 0, S plus 2, 0, 4, 1, S plus 6 dan juga 1. We repeat the first two row of matrix E, implying that we got S 1, 0, S plus 2, 0 and 4. Right? And then we multiply this diagonally, multiply yang ini, multiply yang ini, multiply yang ini, tolakkan dengan multiply yang ini, multiply yang ini, multiply yang ini, which is kita akan dapat the determinant value is equal to S darab 0 darab 1 tambahkan dengan S plus 2 S plus 6 darabkan dengan 0 tambahkan dengan 1 darabkan dengan 1 darabkan dengan 4. Okay. Minus with, okay, we minus with the one indicated by the green line. We got 0 times 0 times 1, 0 times 0 times 1, and then we have 4 minus with 4 times 2 plus 6 plus 2, minus with 1 times 1 times 1 plus 2, S plus 2. 1 times 1 times S plus 2. And then we expand this, we can get our determinant value is equal to, this give us 0. So this also give us, ini adalah kosong, this is 0. This also give us 0. And this is going to be, is giving us 4. Okay, we got 4. 0, this also give us 0. And now here we have to do some calculation. We got 4 minus with, kan ini adalah S kan? Okay, so we got S plus 6. So 4S square. 4S square minus is 6 times 4 is 24S. Minus with S plus 2. So this is equal to minus 4S square. Minus 24 plus minus 3 is minus 25S. And then we got 4 plus 2, we have 6 plus 6. So this is the equation of the determinant value of the matrix E. Okay. We got minus 4S square minus 25S plus with 6. Right. Are you guys with me? Yeah. Very straightforward punya computation to determine the determinant value. So I believe if the questions ever come up in your test and your final exam, you have the options to choose any method that you prefer to compute for the determinant. Right. Why we need the determinant? Okay, of course, the determinant will be used to compute the inverse of a matrix. Okay. Kita perlukan determinant untuk kita kira ataupun dapatkan inverse of a matrix. For a square matrix, okay, for n by n square matrix A has an inverse denoted by A to the power of minus 1. Kalau you see a matrix with the power of the minus 1, that to imply that this is the inverse of the matrix A. Okay, inverse of the matrix A. And the properties, when we have the inverse of matrix A multiplied by its inverse, we will get the identity matrix. Itu adalah dia punya property. If we have the matrix A multiplied with its inverse, we got the identity matrix. Okay. And the inverse, okay, the inverse of the matrix A is given by the adjoint of the matrix A divided by the determinant of the matrix A. So definasi bagi inverse bagi suatu matrix A adalah adjoint A bahagikan dengan determinant of the matrix A. Right. Okay. So of course, this information ataupun this knowledge is crucial because we will be using this technique in order to do some conversion daripada state space kepada transfer function. Okay, mana kita nak convert. For example, daripada transfer function, didapatkan state space punya model. And then let's say you are given a state space model, we want to get back the transfer function, and then we have to use these properties to compute, to do the conversion from the state space into a transfer function. Right. Right. Okay. So let's take a look at this example. Find the inverse matrix for the following matrices. A sama dengan 1, 2, 3, 4. Kita buat yang senang dulu. Okay, kita buat yang matrix A dululah. How will we compute the inverse of the matrix A? Okay, tadi formula inverse adalah adjoint of A bahagikan dengan determinant of A. Right? So what is the adjoint of the matrix A? Adjoint of the matrix A adalah
Cofactor
Satu.
transpose.
ya,
Cofactor and transpose of
cofactor transpose.
yes.
Okay. 1, 2,
3, 4. 1, 2, 3, 4.
1, 2, 3, 4 kan? Ya ke? 1, 2, cofactor of the matrix A. Ingat balik? Okay. Ini adalah cofactor for the matrix A. Ini untuk kes 3 kali 3. So kalau untuk kes 3 kali 2, sorry, kalau bagi kes 2 kali 2, okay, kita tulis kat sebelah ni ya. Katakan we got the matrix A is a 2 by 2 matrix. A11, A12, A21, A22. So what is the cofactor of the matrix A? So let me express this as a cofactor of A adalah, okay, take a look at this.
A2,
So it's going to be A11 minus A12, okay, A minus A21, A22, okay, dan kemudian we got the adjoint of A adalah transpose kan? So it's going to be A11 minus A12 minus A21, A22. Right?
Dr. Syakirin, untuk adjoint A, A11 dengan A22 tu dia swap position.
Swap position.
Betul tak? Dia maintain polarity tapi dia swap position.
A11, A12.
A22. Betul kan Dr. Izan?
Betulkan
Untuk
saya?
Ya,
adjoint A.
betul. Swap position
A11,
between
A22
A11
dia
and
swap
A22.
position tapi maintain polarity.
A11,
A22 swap
Dengan
position.
A22.
ya, nak recall balik. Okay. Kita akan ada A11,
Okay.
okay, determinant of A adalah AD minus BC. Okay, kemudian kita akan ada adjoint of A sama dengan AD A minus B minus C.
Betul.
Kan? Alright. Okay, minus B minus C, AD, A swap position. Alright. So we can get the A inverse of A sama dengan adjoint of A. Okay. Adjoint of A adalah 4, negatif 3, negatif 2 dan juga 1. Okay. Bahagikan dengan determinant of matrix A, yang mana determinant of the matrix A adalah dekat sebelah ni lah, which is 1 over AD okay. Sekejap. Right, let me rewrite this properly. Okay. Dapatkan determinant dulu. So we have the determinant of the matrix A adalah AD, kan? Kita boleh represent A sama dengan A, B, C, D. Right. Determinant of the matrix A adalah AD minus BC, which is sama dengan A adalah 1, B adalah 4, B adalah 2 dan C adalah 3. So kita akan dapatlah 4 tolak dengan negatif 6, kita dapat negatif 2. Okay. We have the adjoint of A adalah B minus AD minus C minus B minus C dan juga A. Okay. Ini adalah D minus B minus C dan juga A. Okay. Which is ini adalah sama dengan D adalah 4, negatif 2, negatif 3 dan juga 1. Okay. And then we can find the inverse of the matrix A adalah sama dengan adjoint of A bahagikan dengan determinant of A. So kita akan dapat ini sama dengan 4, negatif 2, negatif 3, negatif 1 dan dia akan darabkan dengan 1 per negatif 2 dan last sekali kita akan dapat ini sama dengan 4 bahagi 2, kita dapat negatif 2, negatif 2 bahagikan dengan negatif 2, kita dapat 1, negatif 3 bahagikan negatif 2, kita dapat negatif 1, 3 per 2 dan 1 bahagikan negatif 2, kita dapat negatif 1 per 2. Right. So that's how we compute for the inverse of the matrix A. Right. Okay. Are you guys with me?
Yes, sir.
Right.
Yes, sir.
Jadi kadang-kadang benda yang kita dah benda simple kita lupa dia punya macam mana step dia.
Sebab selalu
Alright.
buat yang lebih kompleks. So bila yang simple tu kadang-kadang
Betul.
terlupa.
Right. Okay, so that is the how we compute for determinant of 2 by 2 matrix. What about 3 by 3? Kita sampai pukul apa tadi dah?
Sampai pukul 11 tapi 10.50 tu nak habiskan boleh je.
10.50 ah. Right.
Ah,
Mana yang untuk set space tu tak sempat aku
betul tak sempat.
Yang mana sempat
Tapi sambung lah.
Okay. Okay. Tadi kita dah tengok yang ni kan. 1, 2, 3, 4. Sekarang ni kita cuba pula untuk dapatkan inverse bagi matrix B ni. Yang 3 kali 3. Menggunakan kaedah yang kita dah tengok tadi lah. Alright, let's try to do this example for determine the matrix B. Right. So we know that the formula to compute for the inverse of the matrix B, kan? Inverse of the matrix B sama dengan adjoint of the matrix B bahagikan dengan determinant of matrix B. Okay, determinant of the matrix B. Kita buat yang senang dulu. Let's try to compute for the determinant of the matrix B first, and then we try to figure out the adjoint of the matrix B. Right. So how do we compute for the determinant of the matrix B? So we know that we have 3 methods to use. You can choose either method that you prefer. So let's try to use the second method to compute for the determinant of the B. So we have the determinant of the matrix B sama dengan, so we got 1, 0, 0, 2, 1, 0, and 4, 5, 1. Okay. And then if we were to use the second method to compute the determinant, we repeat the first 2 columns of the matrix B, implying that we have 1, 0, 2, 1, and 4, 5. Okay. And then the determinant can be computed by adding. Yang ni kan, kita tambah yang dulu, tambah yang ini, tambah yang ini, minus with, tolak yang ini, tolak yang ini, tolak yang ini. Right? So senang nampak dia punya pattern tu. Okay? So we will have our determinant is equal to 1 times 1 times 1, 1 times 1 times 1, plus with 0 times 0 times 4, 0 times 0 times 4, plus with 0 times 2 times 5. Okay, plus with 0 times 2 times 5, minus with 0 times 1 times 4, 0 times 1 times 4, minus with 1 times 0 times 5, 1 times 0 times 5, minus with 0 times 2 times 1. 0 times 2 times 1. So we got the determinant of the matrix B is equal to 1 plus 1. Sama 1 Okay. So we got here is 1. Ini kosong kan. Okay, let me check again. Kosong. 1, 2, 4. 0, 1, 5. Okay, 1, 2, 4, 5. So 1, ini kosong, ini pun kosong. Okay, dapat 1 lah. So ini kosong, ini pun kosong, ini pun kosong. Okay, definitely determinant of the matrix B is simply equal to 1. Okay, we got the determinant of B. Determinant of B sama dengan 1. Right. Now, let's try to compute the cofactor of B. Okay. Cofactor of B. What is the formula? Recall balik. Kita ambil the cofactor of B adalah okay, is the determinant of 1, 0, 5, 1. Okay, yang ini kan, kita ambil yang ini. Kemudian kita ada minus determinant of 2, 0, 4, 1, 2, 0, 4, 1. Okay. Kemudian
Plus.
determinant of yang ini pula
2145.
which is 2145. Okay, 2145. Kemudian kat sini minus kan?
05.
Minus determinant of 1,
0501.
0501. Okay, 0501. And here we got determinant
Plus.
of plus with
1041.
1041. Okay, 1041. Yang ini pula
Minus.
tutup yang ni kan? Minus
405.
1045.
405.
Okay. 1045. Yang ini
Plus.
tutup yang bawah ni kan? Tutup yang ini, tutup yang ini. Kita akan dapat determinant of 0010. Yang ini pula minus kan? Juga minus, tutup yang ini, tutup yang ini. 1020. 1020. Kemudian yang ini
1021.
okay. Tutup yang ini, tutup yang ini 1021. 1021. And then we compute the determinant okay, for all these elements to get us the cofactor of the matrix B sama dengan ini adalah 1 darab 1 tolak kali dengan 5 kan? Tolak dengan kosong. So ini dapat 1. Yang ini pula negatif 2. Negatif 2. Ini pula dapat 10 tolak 4.
6.
10 tolak 4 dapat 6. Yang ini pula negatif 0.
Kosong.
Yang ini 1 tolak 4 dapat negatif 3. Kemudian yang ini 5 tolak 1 darab 5, 5 tolak 0 dapat 5, dapat negatif 5. Negatif 5. Ini dapat 0. Ini dapat 0. Ini pun dapat 0. Dan ini dapat 1. 1. Right. So ini adalah kita punya
Bukan negatif 3
cofactor.
tu 1 kah, sir?
Yang ini.
Negatif 3.
Okay, sorry. So ini adalah yang tengah ni kan. 1 tolak 0 which is 1 lah sebenarnya.
Yes.
Thank you. Right, 1. So this is the cofactor matrix B. Adjoint of the matrix B. Adjoint of B sama dengan kita dapatkan transpose of the cofactor matrix of B which is sama dengan
1 negatif 26.
1 negatif 2 6 0
1 negatif 5.
1 negatif 5 0 0 1. Right. Dr. Najidah pakai notation yang sama ke notation berlainan?
Betul.
Okay, alright. So itu kita dah kira determinant of the matrix B which is sama dengan 1. Kita dah dapat adjoint matrix B sama dengan matrix yang ini. So last kali kita nak dapatkan inverse of the matrix B yang mana B inverse sama dengan adjoint of B bahagikan dengan determinant of B which is simply sama dengan determinant of B adalah 1 kan, 1 per 1 darabkan dengan 1 0 0 negatif 2 1 0 6 negatif 5 dan juga 1 which is sama dengan 1 0 0 negatif 2 1 0 6 negatif 5 dan juga 1 lah. Alright. So that's how we do the calculation to compute for the inverse of the matrix B. Right. So I believe that the rest of the problem can be solved as part of your exercises. And then you please try to do it on your own to get to hone your skill to do the matrix inversion. Benda ni kena practice lah. Kalau tak practice memang agak lupa lah. Saya pun dah berkarat tadi kan, namun tak practice 2 kali 2 kan. Biasa guna MATLAB, so bila dah terbiasa guna tool ni, dia akan jadi yang simple-simple pun dia akan jadi mudah lupa. Right. So that is the approach ataupun the method that we can use to compute for the inverse of a matrix. So you have to memorize the formula. Inverse of matrix is simply equals to adjoint of the matrix A divided by the determinant of the matrix A. So the same thing applied for if we have the S in your equation. Okay. So we have the S plus 2 and so on. So we implement the same step for computing the inverse of any matrix. Okay, before yang ini tak sempat ada tadi dah singular and non-singular matrix. Okay, so the key idea about the difference between the singular and the non-singular matrix is for a singular matrix, when you want to compute for the determinant, you will get the value equals to 0. But for a non-singular matrix, when you compute for the determinant, you will get a non-zero value. So that's the difference between singular and the non-singular matrix. So eigenvalue and eigenvector and so on, I believe that this will be covered by your instructors, and then as well as how to do the conversion from the transfer function into state space, as well as from state space to get back the transfer function. You will be using the knowledge that you get from the linear algebra. Mana you kena faham lah inverse matrix, how to compute for the adjoint matrix and so on, because we need that knowledge to do conversion from this state space into transfer function. Okay, I think I will stop from there. So if we have any question, feel free to ask before we end the session.
Any question from the students? Can on your mic.
So far so good, Doctor, sir.
Alhamdulillah.
Hopefully you
Very
can
great
benefit from the
explanation from
discussion.
Dr. Syakirin.
Okay, right, thank you very much. So if we don't have any question, so Dr. Najida, I'll pass back the class to you. So good luck to you guys. I hope you enjoy learning control as I did, because from my degree until my PhD, I do study on control. So it's for those who are find problem in mathematics, dia akan rasa control ni susah lah. Tapi for those yang enjoy mathematics, dia akan rasa control ni very interesting lah. Right.
That's
Okay,
right.
I think that's all from me. Thank you very much again. Thank you very much for inviting me to have this this session, and hopefully we can collaborate more in the future lah. To
Sure.
have an instructor from UiTM as well to teach our student to do this kind of teaching, collaborative teaching, inshallah. Right. Thank you very much, Dr. Izan and Dr. Najida.
Thank you, Dr. Syakirin.
Okay, for all students, please do not leave this session yet. Please on your camera so that we can snap a picture together, because we have to send evidence for the report. Please on your camera. Baru nampak muka diorang kan, Dr. Syakirin?
Betul lah. Dia duduk kat kampus ke dia dah still online lagi, UiTM?
Campus.
Kampus lah. Masih
Hmm.
buat memang ada kelas secara bersemuka masih berjalan kan?
Ya, tapi kita ada beberapa persen yang kita boleh buat online for blended learning.
Blended learning punya
Sebab
approach.
memang dah set dalam kita punya syllabus kan, dalam SLT. So memang kena few percent buat online, few percent lagi buat face to face.
Alright, interesting.
Boleh on kamera yang lain-lain. Siapa yang boleh, student siapa yang boleh snap picture nanti snap dan share pada saya ataupun Dr. Izan. Saya pun akan snap juga. Terima kasih banyak Dr. Syakirin. Thank you Dr. Syakirin for his willingness. Actually, I offered this collaboration to some other lecturers, but Dr. Syakirin willing to join us for the second time, and I hope for the next time, for the future years, he's still willing to join us for the collaborative teaching for this subject and the other subject too, inshallah. Okay, for all
Inshallah.
students, don't worry because you can rewatch this video because I record using Teams and will download and upload in YouTube later and I'll share with Dr. Izan for the other two groups. Yang lain tak ada nak on camera? Okay,
How
kita
many
boleh snap
students that we
picture.
have here?
My students about 48. Dr. Izan, how many students of you?
Sepatutnya dalam 50 something tapi dia orang pun banyak ada kelas juga. So dekat sini
pagi
dah
ni start ada kelas.
so tapi kiranya kalau dia kan overall kita ada 100 and something lah. So
Okay.
kiranya more than 70% lah dah attend.
Alright.
Kalau di UMP around this one kita buat satu group mass lecture je kan. 30 item kita divide into 4 groups. The maximum around 30 to 35 students lah for per group.
Per group. Okay.
Okay, kita
Alright.
boleh ambil gambar. Yang lain pun boleh snap picture. Okay, smile, 1, 2, 3. Okay. Thank you everyone. Terima kasih Dr. Syakirin. Thank you students for
Okay,
joining
terima kasih semua.
us.
Thank you, doktor. Thank you, sir.
Okay, terima kasih.
Thank you semua.
Thank you, doktor.
Thank you, doktor.
Thank you, doktor.
Thank you,
Thank you,
doktor.
doktor.
Thank you,
Assalamualaikum, doktor. Assalamualaikum, sir.
Okay, doktor.
Thank you, doktor.
Terima kasih
Okay,
banyak
saya boleh live dulu ya.
Syakirin.